So in this video, we'll start looking at the way to find the volume of certain solid. The name of this method is called the disk method. And let's look at the current picture. So please look at the current picture now. If I ask you to do the following thing, you look at the x-axis as a rotation axis, and you look at the shaded region here, and I'm asking you to rotate this region for 360 degrees in a three-dimensional space along the x-axis. Can you imagine what kind of solid you're getting? So roughly speaking, you're getting a picture here on the right-hand side. I just sketched it here. And essentially, it's a full solid in the sense that you can imagine that there's a purple liquid filling up the whole cylinder here. And formally speaking, it's not really a cylinder because you see it is curved in the outer layer. But anyway, I hope you can kind of understand what I'm talking about by rotating this purple picture along the x-axis by 360 degrees. And the method, which we call it the disk method, is help us to find the volume of such a solid, which is filled with the purple liquid. And please recall the following concepts. If you recall, to find the area of this picture, which is two-dimensional, you can imagine that you're kind of giving the slice, like the vertical slice from the point A to B. And when you keep cutting it, and if you keep going on for this process, you keep making the slice thinner and thinner by doing more vertical cuts. And at the end of the infinite process, you're getting a slice which is infinitely thin. So in general, to find the area of this picture is kind of like the sum of the lengths of each slice, right, from A to B. And it's an integration problem from A to B, and I've explained it in the previous video. Now, let's look at the current case, which is this picture, which is three-dimensional. Please imagine what's happening. If I take a vertical thin line, which is somewhere between A and B, essentially you are trying to rotate this red line by 360 degrees along the x-axis. Can you imagine what you have in this picture of the solid? You are actually getting a red circle which is full in the red color on this picture, right? And by thinking of the integration from A to B as a summation of something, I think we can talk about this problem in this way. First, this disk, we can call it a disk. The fact is that for every red line on the left-hand side, you can always draw the corresponding red disk on our solid, right? So what does it mean? It means that, informally speaking, you can think of our volume of the solid to be the sum of the area of a disk. And of course, there are so many disks you can draw because each disk is based on one red line on the left-hand side, right? And you have to count all the disks here. So essentially, you're counting the disk from the leftmost point, which is x equals A, to the rightmost point, x equals B. You can think of it like this. So basically, if you sum up all this area of disk from the point x equals A to the point x equals B, informally speaking, it looks like we can get the volume of the solid, and mathematically it is actually true. And as I told you in the previous video, this summation process is basically an integration problem from A to B for the x-axis. So I have to put the x here to represent the fact that you're going along the x-axis. And what is the item inside? The item here actually correspond to the area of a disk. And because our disk here, you see, is always circular, which means that the formula is the same as the area of circle. The area of circle is what? It is pi r square, right? So let me put it in. The area formula is actually pi r square. And we have to check the meaning of r. And r actually means what? R actually means, if you look at the red circle on the right-hand side here, is the length from the x-axis, which is the rotation axis, up to the curve here, right? And this length, if you come back to this picture, is essentially the length of the point standing on the curve, which is essentially the y-coordinate of this point, right? And the y-coordinate, of course, is f of x, and x is depending on which point you choose from A to B. So it means I can just put the formula here. And now, if you understand what I mean, that's basically the volume formula we have for a solid like this. And let's look at some examples. So please look at the current picture here. I give you a simple example to start with as a practice to write down the volume formula based on our disk method in the previous page. I actually just give you a straight line, and I would like to do an x-axis rotation now for this shaded part in the purple color. And please try to imagine spatially what kind of picture you're getting as a solid. And if you have a good spatial imagination, you could actually see that you are actually getting like a solid like this. And this solid you get is full in terms of purple liquid inside the cylinder. And after rotation along the x-axis by 360 degrees. And basically, now I would like to ask you for the volume of the solid right here. So I put the formula in the last page in the black box here, and I hope that you can tell me the formula of this volume. The lower limit is A, and the upper limit is B for the integral. And if you look at this picture, it should be from 4 to 5. And let's look at the content inside the integral. The things inside the integral should mean the area of a circle, which has the radius of a straight line like this, depending on the point you use here, right? And as we have mentioned here, such a radius here is exactly the function f of x, and that's why I just put the function f of x here, which is 2x plus 3. And of course, the remaining calculation, I trust that you're able to finish that, but I'll try to write down all the steps here. So to save up a bit of time, I actually write down all the calculations here, and of course, you can check the answer by using your calculator. And let's come to the next example. Please look at the current problem now. I'm giving you a picture here based on the curve y equals to x cubed. I ask you to rotate this along the x-axis by 360 degrees. And can you try to imagine what kind of solid you're getting? So roughly speaking, you're getting a picture here in the purple color. So I would like to ask you the volume of such a solid by our disk method. And now let's try to write the answer. If you recall, it is an x integration because we are integrating along the x-axis from 1 to 2. And the content inside the formula is actually pi r squared, like this. And what is r? The r is exactly the length of such a vertical line because it represents the radius of such a disk. And this length is based on the function you have, which is 2x cubed. And essentially, this formula will give you the volume of the purple picture here. And of course, I can write down the computation here. So you can look at the steps here. I'm saving up some time. I'm just writing all the steps here, and I trust that you're able to do the calculations here. And actually, for this chapter of finding the volume of a solid, the most important thing is to write the formula down, and the remaining calculation is actually quite clear to you. And that's the end of this video.